So we learned that what is a naive model. We learned that what a naive model is. We learned that why we need a naive model. What is its role? Now let's talk about how to define it and how to use it in practice. Naive model is the least sophisticated model that we could have. So this is something that we pointed earlier. Let me change the color because it's quite important. For regression problems with a target variable called y, the naive model prediction is the average y for any observation on the training dataset. So this is the case. You have a dataset, you divide it to a training and a testing, and you define the naive model on training. And how you define it? Well, the outcome of the naive model is the average of the target value. So this is for regression problems. So for instance, we want to predict the income of our students after graduation. We have a data set of former students that they have graduated and they have found a job. So the testing part would be for evaluation of our model. The training part would be part of our historical data, and the target, the income, which is here, it has many different values. Let's say 25K, 15K, 18K, 35K, 55K, 40K, 28, 25, 27, and so on and so forth. So the naive model says that, okay, I don't care about predictors. I only look at I'm very simple, and I'm not sophisticated enough to look at the predictors. I only look at the targets. What is the average? And we say that the average is 28K, let's say. Okay, so this is the average of the target, 28K. And the model is like this. It says that, okay, any new case that you give me, my prediction would be 28K, regardless of the determinants like gender, like the GPA and marks, like the skills, like the background, and anything. I cannot consider any of those determinants. I do not consider any predictor because I'm the naive model. I'm the least sophisticated. I'm the simplest model possible. I only care about the target values of the training and their average. So for any new case, my guess is 28K. So if these are the predictors of the test set, so predictor 1, predictor 2, predictor 3, predictor 4, predictor 5, I do not care about them. And my guess is 28, 28, 28, 28 for all of the cases. And now we have the predicted values and we have the actual values of the test, so we can calculate mean absolute error, we can calculate root mean square error. And this would be, so for instance, we calculate mean absolute error, and this would be our benchmark. This would be our starting point. We want to outperform this null model.